Hello and welcome to the next episode of Spec Stepping, where we are stepping through the web API spec. In today's episode, we're going to cover compression streams, the compression stream API. So when you think of compression, basically those are algorithmic ways to make files and folders smaller. So the common one would probably be the zip. Everybody out there who has spent any time at all on their computer has probably zipped a file or two or a folder or two. And when you're talking about communicating across the web, MP4 for video is also considered a compression algorithm. It makes the video size smaller. So we're constantly trying to be more performant, make things smaller and stuff. So in the past, prior to this API, we had to use compression libraries, which did the job, but it also required more overhead from a JavaScript programming standpoint because we had to have those libraries installed and things like that. So this API allows us to use JavaScript to compress and decompress data into gzip or deflate formats. And so I personally use gzip a lot. So it allows you to not have to have the need of a library, a third-party library to do compression. So making download sizes smaller. So think of this like being able to have users select items, documents, whatever you're providing to them, and then they click a button to download, and you can then take that and you could use it on the node side and zip it up and submit it, or you could have them fetch and zip up everything and submit it or upload. And so it zips locally. So if someone takes a local document, uploads it to your service, whatever you're providing to them, you could zip it up to have it do faster. So provide a better user experience for that user. So there's a bunch of interfaces. I'll leave it to you to take a look at the excellent documents on the Mozilla Developer Network. It has some examples. It's available on all browsers as of the recording of this video. So let me go ahead and just jump into the demo, and then I'll jump back to the code. So here in this demo, you're going to see that I can choose whatever algorithm I'm going to use, and I can type some text. So actually, I prefer, a lot of people use lorem ipsum. I prefer bacon ipsum. So let me grab some text here, and I'm going to come over here and I'm just going to paste it right in there. So here I'm going to take this text and I'm just going to click compress here. And so this output, it's just showing that I used gzip. The original size was 2.1K. It's now compressed to 791 bytes. And it just shows the first 64 bytes in hexadecimal format. I can actually pick a file to decompress. So I can pick a JZ file or deflate a decompressed file to do that. Or I can use a streaming to decompress from a fetch. So I can enter a URL to a gzip compressed file and pull that back and fetch it and decompress it. So let me jump over to the code and show you some of this, and then I'll come back and demo some of that. So the HTML is pretty straightforward. It just has the layout where I choose the algorithm, text area, buttons to compress, decompress. Same thing with compress, decompress files for streaming. You can pick a file to compress, and then also for doing it from the fetch. Okay. So just basic layout, basic HTML stuff, and styles are just pretty minimal as well. The real magic happens here in the JavaScript. So I have a function that to see whether it supports compression streams or not. That's always a good thing to check. So here I'm just checking to see whether it supports it. That basically, if I go back here, puts that on the screen right there. So I know that I'm working in a browser supports it. You could do some more complex logic in a production app where you could give them a message and maybe redirect them to another service or what have you. And then I have these helpers where I'm just doing some encoding of the text so we can see the bytes. And here I have this function that converts a readable stream into an array. So I have this method stream to uint8 array. So it just That grabs the response array of buffer and returns it. And then I can convert to a readable stream to a blob right here. So just pass it through and convert it. And again, with this response method, works great. And then I have this compress to a uint8 array. So I can choose what algorithm. I have defaulted to gzip. It doesn't mean you can't use other ones, but I'm using gzip, turn it into a readable stream via blob and pipe it through a compression stream. Okay. And then here I'm decompressing a uint8 stream right here and piping it back through and using the decompression method. Again, all of these, if we go back to here, because I know I'm going through this quick and this can be a complex feature, there are all these interfaces and stuff in here for compression, decompression methods, all that stuff. Okay, so going back to here, I then have the function that will compress or decompress the text here. So it takes the text, takes the algorithm, and uses the encoding method and runs this compress int u8. Then here decompress it. Then I have a blob version for files, so I can take a file and compress it or decompress it. Same thing here with the blob of decompressing. And then I can figure out what the size of the file. This is just a helper utility that helps figure out the size of the file, like I did here to figure out the sizes here. So I just have that there just to help just to do the math so we don't have to do it in other places. So here I'm just grabbing my handlers from the demo, and then here I'm adding a click event listener for the compression text. This is the one you saw me demo where I entered some text and then it ran all the compression stuff that I showed you, and then basically provided the result where it provided that what was compressed, what the original size is. So if I see here, if I go back, so I compressed it with gzip, the original size I grabbed using that pretty bytes up here utility. So I grabbed what the original size was, grabbed what the compressed size was, then just did a little ratio just to see what the compression ratio was. 37. You could turn it into a percentage if you wish. And then just grab the first from the sliced off the first 64 bytes of the hex. So just to show you kind of here what the 64 bytes for what the zip looks like. And then I just disabled the button up here. So I can then decompress it if I wish to do so. I can decompress it back to right here, the original text. So I can compress it and decompress it back. So I can do it on the fly where I can send across compressed text and decompress it and with any sort of event. I'm using a button just for demo purposes, but any sort of event. And that's what this decompressed function right here, or this event listener, I should say, does. Okay. I also have the same thing here for the file. And I'm just going to refresh to clean it up a little bit for my files for streaming and files for fetching right here. So same sort of process. It's just now I'm doing it with files and URLs. So here I've got to grab the file and do it that way. And I've got to grab the URL down here and fetch it and do it that way. So, and that's these two examples. Okay. So now let's take a look at the compressed, decompressed file streaming, and then I'll go back and just review the code here. So first I'm going to have a file, have it just a simple text file, just something that we can use to play with and see what it does. So it's not a huge file, but it'll work. So I'm going to pick a file to choose. I'm going to choose my file demo. So now I have file demo here, and then I'm going to compress the file. And the original file, 409 bytes, again, not very big, but it did compress it to 279 bytes, so ratio of 0.68. And then I can download now that as a gzip right here from this link. Go ahead and click download, boom, it has now been downloaded. Okay, so then you can also decompress. If I choose a file, I'm going to go to my downloads where I just did that one, and I'm going to decompress that. And so it decompressed back to the 409 bytes, and it just showed me a little preview of the file. It's going to have some of that gobbledygook at the top, but then here, this is to demo the file compression decompression. So I was able to decompress that. So again, what's also nice about this is with blobs and stuff, you don't have to load it all into memory at once. So there is an advantage there to doing that. But if I flip back to the code here, let me go back up to this file compress decompress demo section, and I have it commented so you can see it in its bytes here. So basically, I just grabbed the pieces of the DOM that I needed, listened for any changes to the buttons and all that stuff and the files that I'm grabbing. So I can grab the files, and then I'm just seeing whether I'm using gzip or deflate. But basically, I'm just using the API methods to zip it up, and then I'm just creating that link on the fly to be able to download it and to put that back onto the page. But basically, I'm compressing it blob to blob with what the files, with the algorithm. And then here is actually where the compression takes place. Or I'm sorry, the compression takes place up here. Decompression takes place down here. So again, I added a click to that where I just grab that file, and I basically do the opposite, where I then take that gzipped file and I just decompress it back into its original file. And then I put the information on the page where I'm showing what the decompressed size is and all that stuff that you saw. So I would encourage you to play with it to see how it works. It's pretty cool how you can take a file, zip it up. It makes it more performant that way, not just for exchanges across the network, but internet, but also for your memory and things. So it's a pretty helpful little tool. So now let us move on to the streaming ability to decompress from a fetch. So imagine you have a zip file and you have it zipped to make it fast across the internet and stuff, and people can fetch it faster. But then you want to make it easier, so it just decompresses and unzips on the user side. So I'm going to use the same file that we compressed and decompressed up here. And if I put it in here, so here's that file demo. And so if I then, this is just the URL, I have it locally. So you would need whatever URL. And just a side note, you need to take care of CORS issues and all that stuff. But I'm doing it locally here so that we can just demo without all that hoopla with fetch. So if I click fetch and decompress, boom, it pulled it down. And this is that same file. This is the demo file to file compression, to demo file compression decompression. So same sort of result I got up here when I just picked a local file and decompressed it. The difference is I got it through a URL. So I fetched the content by clicking the button. I have the grab the button here and added the event listener, and it just grabbed it, pulled it back down, and then it piped through and decompressed it using the API. And then I just showed a truncated version of the file decompressed on there. So now, as a related note, I have this. I don't have a demo of this, but I have this listed in here just as an example where this is available in web workers. If we go back over here, let me go up to the top. This feature is also available in web workers. So this is going to be pretty handy. And if you don't know web workers, that's beyond the scope of this video, but basically it allows you to offload some work that's outside the normal stream of the work. So for performance reasons, you do it with a lot of heavy duty, heavy lifting work in an application. So you don't have the spinning death, haining notification of an application, but you can offload it to web workers. So here I have an example of code where you can offload it to a web worker, and I will put this in the repo as well so that you can have this and play around with it. But basically I can offload it to a web worker so that I'm not waiting on the UI side. So what does this mean? Let's say this is a big these are big files I'm working with, and I click fetch and decompress or whatever. Instead of waiting for it to download and waiting for it to decompress, I can offload that to a web worker. I, as the end user, can go through and do whatever I want because my UI is no longer blocked by that download process, and the web worker is tending to it in the background. So that's what this piece of code shows you to go through. And I have a little example of it down here that's commented out that you can mess with it and stuff and send messages to the end user to let them know it's been updated and been downloaded or whatever you're doing with it. So this has been a very quick overview of this compress, decompress AI for compression, or API, I should say, for compression streams. So it's a pretty cool tool. I would recommend using it, particularly if you are dealing with very large files, folders that you are sharing and allowing download and upload from your application. So if you have any questions, let me know. And if not, happy stepping.